All right, ladies and gents, I'm going to spend a little bit of time giving you an ionic bonding review because I think we need it. So first things first, right, an ionic bond is one that combines some sort of metal with a positive charge with a nonmetal with a negative charge. Right, a positively charged ion is called a cation, and a negatively charged ion is called an anion. Okay, so those are the things that we're going to be playing with today. The first thing to recognize is that in order to write a compound, you must have neutrality. If you don't have a neutral charge, the formula is not correct, right? So this is your guiding principle. That's what you want to be creating anytime you write a formula. So let's say you've got calcium and chlorine, right? There are two kind of ways to go about this. We worked with flashcards, and the size of the card relatively showed you the charge of the card. So obviously here, to make that nice rectangle we did in the activity, you would need a second chlorine. And now you just count. I have one calcium atom, and I have two chlorine atoms. So there's my formula. Another way to look at it, you've got calcium 2 plus and chlorine. Right now, if I were to add these together, right, I would get a positive 1 charge, which is not neutral. So I need to add another negative chlorine. Now I have a negative 2 and a positive 2, which gives me 0, which is what I want. All right, so again, we count. I've got 1 calcium and 2 chlorines. Third option to go about formula writing is the crisscross method. I take the charge on my cation and make it the subscript of my anion. Then I take the charge of my anion and make it the subscript of my cation. Now, if I wrote that exactly as is, it would look like this, but we know that that's unnecessary. So we can write it like this. Okay. A couple of other things to keep in mind with crisscross. Really, I guess just one more thing. If you have something like this, remember, this is the bottom line. This is what's most important. Right, so as we come back down here, hopefully you see that that's the formula, right? Positive 2 and negative 2 is neutral. But if you crisscross, you get that, which is not correct. You would have to reduce it, right, to the actual formula in order to receive full credit. Parentheses are things that sometimes trip students up. Notice there are no parentheses on any of these compounds. Okay, the only time you're going to use parentheses is if you need more than one polyatomic ion to make the formula neutral. So let's say, for example, you were bonding ammonium to sulfur. Right, and this is the one exception to this rule, metals being positive. This is our one positive polyatomic ion. Right, so in this case, no matter how you work it, you're going to get this as your formula. Okay, I need parentheses because I need 2 ammonium ions to make the compound neutral. Right, a lot of students will try to write it like this, or like this. Some will go here. Right, so I'm going to take these one at a time to kind of highlight issues. 1, this implies that there are 42 hydrogens, which is not the case. This implies that there are 8 hydrogens. There are, in fact, 8 hydrogens, but there's only 1 nitrogen. There are 2 nitrogens. This has the correct number of atoms, but it doesn't show me that this is the ion that I'm working with, right? It implies that there's some sort of bonds happening here. That's not the case, right? The bond is happening here. Going through this from a more, I don't know, I guess conceptual framework, right? Every set of NH4 has lost 1 electron to sulfur. Right? For each of those, when it loses an electron, it becomes positive. And sulfur gains the electrons, and it's gained 2 of them, so it becomes negative, right? And that's where these charges come from, okay? If this is on the periodic table, you can determine its charge by recognizing how many electrons it needs to gain or lose to look like a noble gas, right? Remember, oh geez, here we go, drawing. All right, these are your noble gases, stable octet. Okay. I think that's really the bulk of it. I'm going to scan through just a second and be back with you. So I just skimmed through my notes, and that's really the bulk of it for ionic bonding. I'm going to make another one for covalent bonding in just a second, but that's really the nuts and bolts of it. I hope you found this helpful. Have a good one.